Now see here, de Broglie's explanation of Bohr's second postulate of quantization. You know, we have done already the Bohr's second postulates. Revolving electron around the nucleus in any orbit has got angular momentum, which is integral multiple of the h upon 2 pi. So, we have done that is mvr is equal to nh upon 2 pi. This one was explained, or this thing was solved by de Broglie, because when electrons revolve around the nucleus in a definite orbit or in a stationary orbit, these moving electrons behave as waves. So, you know, just like we have done the stationary waves in a string, when the string is plucked, number of stationary waves are formed, and that we can see also here. So, when the electrons are revolving around the nucleus, these moving electrons are behaving as a wave, and these associated wave has been made here. Suppose electrons are revolving in a nth orbit, then the total distance covered can be here 2 pi r n is equal to n lambda, number of the wavelength formed, that is the integral multiple of this total distance is equal to n times of the wavelength. According to de Broglie, we know lambda is equal to h by mvn. Vn is the velocity of the electron this nth orbit. So, we can write 2 pi r n is equal to n h upon mvn, and now we can write mvn r n is equal to nh upon 2 pi. So, this is the angular momentum of the electron in the nth orbit, and this is your h upon 2 pi. So, the angular momentum of the electron in the nth orbit is integral multiple of h upon 2 pi. So, this concept or this quantization concept was explained by de Broglie by assuming that, or by just giving this concept, the moving electron or any moving particle behaves as wave.